Okay, we're going to look at an electron beam scattering foil. So I have here an electron beam scattering foil. This one is for a 16 MV electron beam. You can see it's all metal. There's no cooling lines on this one. You can run this in a LINAC 24 hours a day, 7 days a week. It will not get hot and it will not get cool because most of the electrons impacting this are not transferring energy. They're simply scattering. And you can see it's got this weird arch thing on top. The beam's going to come down and hit right here. It's going to start an initial scatter, and then it's going to come in towards that cone of what to me looks like aluminum and scatter again. And so the scattering foil, it kind of has like this, I call this like a dual scattering foil system. So you got this pyramid of aluminum on the bottom, right? That's what we see right there. And then we have this scattering foil on top. It's all inside this cup. And it's got this bridge coming up and down to hold it all. So in this example, we're going to have a 16 MeV electron beam. It's going to come down and hit this initial foil. It's going to hit right there. And it's going to scatter probably kind of like this, right? They probably designed this cone of aluminum on the bottom to catch this. So all these electrons are going to come down and scatter on this bottom cone, and then they're going to do another scattering after that. So it's like they're all going to go different ways. It's like two scattering systems, two stages of scattering. This material here looks like it's stainless steel or something like that. Doesn't appear to be aluminum. This one down here does appear to be aluminum. How much scattering you get is a function of Z. So obviously this foil wasn't enough to scatter a 16 MeV beam, so they needed to put another scattering foil down in there. And remember, for this to work correctly, this isn't at the same position of the focal spot of the LINAC. So if you remember, the LINAC has an X-ray target on top, which normally the electron beam comes down and hits, produces X-rays, which then come scattering down through the primary collimator of the machine, and eventually down to like the flattening filter, right? This is for X-ray mode. But for electron mode, this target's out of the way. So here's the primary collimator of the machine. The target's pulled back, X-ray beam comes down, flattening filter is rotated out of the way, and then we have our little dual scattering foil in here with this little pyramid. So it's going to come down here, it's going to scatter once, it's going to scatter twice, and send these electrons down. And then the interesting thing, you may remember, like LINACs these days are basically 100 centimeters from X-ray focal spot down to the axis of rotation of the treatment machine. Essentially the same thing, but the scattering for this electron is happening lower down in the LINAC, so it's not exactly 100 source to surface. The SSD is still here. This is still 100 right here, but the foil is further down in the machine, and it's scattering from a distance. So electron mode does not have exactly the same source to surface distance that the X-ray mode uses. We don't try to correct for this, we just use it as is. If you have a 100 cm SSD set up for electrons, you're going to put the surface of the patient right at 100. And then beyond that, electrons are a little weird. So electrons have their kind of own inverse square law, and they scatter differently than photons. So even though this foil is high up in the LINAC and it's scattering electrons, it's not going to have the same inverse square law that X-rays do. So that's the basics of a LINAC scattering foil.